Welcome back to Physics with Miyoshi. Today we're going to talk just a little bit more about Newton's law of universal gravitation and Newton's second law. Today we're going to think about a little thought experiment, if you will. What would the gravitational constant be on Mars, and what would a person or somebody or something on Mars that has a mass of 65 kilograms weigh on Mars? To figure out the gravitational constant on Mars, we would go back to our law of universal gravitation, and remember that the force is the gravitational constant times the mass of the one object times the mass of the other object divided by r squared. Well, we don't really need to have the other object to find the acceleration, because we can just use part of the equation to think about the acceleration, because we do remember from Newton's second law that F is ma. Okay, so if we plug in, instead of using the Earth's mass and the Earth's radius, we can use Mars' radius, which we have up here, 6.46 times 10 to the 23rd kilograms. And, oops, did I say radius? That's its mass. And we can use Mars' radius of 3.39 times 10 to the 6 meters. Plug that in over here to our equation, remembering again, like I said, F equals ma, so we can consider this guy here, G times m over r squared, to be our gravitational constant on Mars. So then we just plug those guys in, G, the mass of Mars, divided by the radius of Mars squared, and we put these numbers in, and we get 3.75 meter per second squared. If you watched one of my previous videos, you'll remember that I went through the units and found that these units really do convert back to meter per second squared. To find out how much a object, the 65 kilogram, weighs on Mars, we would just use, again, Newton's second law, and find that the force of weight on Mars is the mass times the acceleration, or the mass times the gravitational constant on Mars. And we can just use that same number we calculated down here and find 65 kilograms times 3.75 meters per second squared gives us 243.8 newtons. Notice we also could have gone through this whole big equation over here and plugged in these numbers and put the other mass over here and found this same number, or we can just take our result from before and use that over here as our gravitational constant. Either way would work, and they should give us the same results. And again, we would check our units. A kilogram times a meter per second squared is a newton, so we should come up with the right newtons. So if you think about this, knowing that the gravitational constant is 3.75, or Calvin calculated that just now, and knowing that the Earth's gravitational constant is 9.8 meters per second squared, somebody on Earth would weigh about a little less than half on Mars. So it's not quite the weight reduction plan that I would choose, but you could do that and have the same mass and be less than half your weight on Mars. So thanks for tuning in again, and we'll see you next time on Physics with Miyoshi.